On to our final video for section 4.3. This one's going to be reading some different computer outputs and trying to get regression information from them. Again, very much like you're going to have on your final exam and stuff, because I give you a lot of outputs in those and you have to interpret them. All right, so UNESCO collects data from countries on their female literacy rate, i.e. the percent of women who can read and write in that country, and fertility rates, the average number of children per woman. Following results from 112 different countries in 2007. The first few data points and the corresponding scatter diagram are shown below. So here's the first few countries are listed up here in the table, and then I have a scatter diagram right here. All right, so then I use 3 different computer programs to create the linear regression equation and some other stuff, right? So it does actually a whole bunch of junk that we're not talking about right now, but if we got into chapter 14, this stuff would be really exciting, I swear. Okay, so this is Excel. This is a different kind of output than we've used in Excel. I never taught you how to get to this. That's because some people don't have the full program, and so they can't do this. You need a data analysis tool pack to be able to make this happen. All right, and then don't worry about my highlighting. I'll get back to those little colored boxes in a second. Then here's the StatCrunch output right here. And then here's Minitab right here. Okay, so first question, what program did I use to make the scatter diagram? So if you look back up, hey, look at that scatter diagram. And then you look very quietly at the other programs that I listed, and you realize that it must have been Minitab. Because if you look at the Minitab graph, oops, there it is right here, you can see that's of a very similar style. So Minitab is the program that I used to make that scatter plot. What is the response variable? The response variable, remember, is your Y variable. So your response variable was the female, children per woman. That's your response variable. I don't know if I have that right. Let me go back. Oops, I have it reversed. See? Children per woman. Got so used to putting in the explanatory first. Explanatory is the fertility rate. Or, excuse me, I'm losing my mind. Literacy rate. Female literacy rate, I should say. Okay, and the response variable is the children per woman. Whew. All right, again, I'll say it again. So female literacy rate, that's your X, that's your explanatory variable, right? And the response variable responds to changes in this explanatory variable. So your response variable is children per woman. Alrighty. Now, what was the correlation coefficient? And circle in each output if you can. So it's R. I put a little green box around it. So let's go back and look. Now, Minitab, interestingly enough, is not giving it to me here. Minitab actually can find it. Minitab can do anything in the kitchen sink, I swear. But it's just not in this particular output. It doesn't mean it won't ever be there, but it's not in that one. StatCrunch finds it right here. It says the R correlation coefficient right there, negative 0.7512. That's the one. And then up here in this particular Excel output, it's right there. It's called multiple R. Now, what's interesting about this is that if you look at the graph, you realize that R must be negative because this is a descending line. But Excel, like most other things with Excel, doesn't know that. It's obvious the people that make this program are not mathematicians, I swear. So anyway, it's got to be negative 0.75. So if you're going to use Excel or if you're going to read this output, you have to be careful and realize that it must have been negative, even though Excel doesn't tell you that. StatCrunch is a much better program for this kind of thing, and it tells you right away it's negative. Minitab would tell us negative, but I didn't have it find it. Okay? All right, so note that you might want to make a note to yourself, like Excel might not tell you it's negative. You got to look back at your scatter plot and make sure you know that it's negative. Speaking of which, what kind of relationship is there? Well, it's negative, right? It's a negative linear relationship. Of course, because R is negative, but also because you have a negative slope to this regression line here. And that's just on a side note. If you have a negative R, then you're going to have a negative slope, right? These go hand in hand. You can't have a negative R and have a positive slope. That's not how it works. All right, what about the relationship? Well, because R is around 0.75, that's considered a moderately strong relationship. Remember, we learned that way back in section 4.1. I'm not going to go back to it, but there was a table at the bottom of a page. Okay, fine, I will go back. Hold on, let me find it. Here it is on page 8 of the chapter 4 notes. So right here, we said if it was between negative 0.79 and negative 0.5, that's a moderately strong or moderate negative linear relationship. So that's what we've got. Oops, there we are. Scroll up to it. Okay, now what about your critical value? So find the value of your critical value. Well, that's going to require we go back as well. So that was on page, I want to say 10, 7, 8, 9, oop, wait, there it was. 12. All right, I was wrong, page 12. Okay, remember we had this table of critical values, and you want to find your n. Well, the biggest the table gets to is 30. Our n is bigger than 30, so even higher. But notice what happens to these r values. They go down, down, down. So anything bigger than 30 will have a value even smaller than this. So what we're going to do is we're going to, I don't know what I'm doing there. We're going to go use the best value we can, which is the one for 30, which is 0.361. I think I said it right there. So n is greater than 30, so just use 30. You know, anything larger than 30 for your n, just grab the 30 number, which is r equals 0.336. Our number, r, the absolute value of it is 0.75 positive, and that's greater than that 0.336. So yes, a linear relationship was what we had. All right, what is the coefficient of determination? That's r squared. So I put it in red box, so let's go see. Minitab does give us that one. R squared is 56.4%. Here it says RSQ, that's r squared, 0.564, 56.4%. And then right there, r squared, 0.564. Okay? Now what does that mean? Well, that's from section 4.3. That means that 56.4% of the variation in the fertility rate for women and or of women for a country can be explained by the least squares regression line. In other words, 56.4% of the variability in Y, your fertility rate, can be explained by your model. All right, what is the linear regression equation? That was Y equals negative 0.0487 x plus 6.8. Now, how did I get that? Well, it's in here. It's actually in a couple places. So you can, in Minitab, they write it out. Children per woman, Y equals 6.8 minus 0.0487 times X, female literacy rate. They also have it down here in this little box, right? If you know what you're looking at. The constant is your Y-intercept, 6.8. The female literacy rate is your slope, negative 0.04. 048, I should say. StatCrunch is the same way. They write it out this longhand way. Children per woman equals 6.8. They're kind of doing B minus MX instead of MX plus B, but it works, right? So there's your B, 6.8, minus, there's your M, your slope, 0.0486, times your X variable, female literacy rate. You can also see it right here in the table. There's your Y-intercept, 6.8. There's your slope, minus 0.04866. It's always a little backwards sometimes in these programs. Instead of doing MX plus B, they do B in first and then MX in the back. It's okay. Don't freak out. Just flip it in your head. See, all three of these programs do this. Here's your intercept up here, your B first, and then there's your M right below it. This program doesn't actually write it out, and that's because, remember, Excel writes it out for you when it writes out the equation on your graph. So if you really want to see the equation, you have to make a scatter plot. Not a residual plot, a scatter plot of the real data, which we don't have, so we're not going to do it. All right. Done. So I boxed all those in orange. Now, what is the slope? Well, we just talked about it. They show it, let's see. Here, female literacy rate, there it is, 0.0486, negative 0.0486. This one, I love StatCrunch. They tell you it's a slope. Right there that says slope. But it's also up here, 0.04866. And then female literacy rate right there. StatCrunch is the easiest to read of all of these, at least for a beginning math student. So the slope is negative 0.0487. Remember, that's really negative 0.0487 over 1. Remember, because it's vertical change over horizontal change. Matter of fact, I'm going to write it like that. Negative 0.0487 over 1. Okay. Now, what does that mean? Well, you have to explain both numbers. So every time the x, and I'm just going to remind everybody, just real quick, this is change in y. Hold on. Change in y over change in x, all right? So if that's the case, then you say, okay, every time my x changes by 1, x, remember, for us was, go back to the scatter plot, the female literacy rate. So anytime the female literacy rate increases by 1%, so when the women's literacy rate in a country increases by 1%, 1 because it's on the bottom, we expect the average number of children per woman to decrease by 0.0487 kids. 0.0487 is fine. All right, what is the Y-intercept? Well, the Y-intercept is also given in most of these problems, or most of these outputs. It's right here. It's the 6.8. It's their constant coefficient, 6.8. Constant because it has no variable with it. There it is. It calls it the intercept for Excel. And here they just say intercept. I love it. 6.8. All right, what does that mean? So it's, first of all, it's a point. It's actually 0, 6.8. Now, that means you have two numbers to explain. So what's the 0? 0 is your X. That was your female literacy rate. So if a country had 0% female literacy, then we would expect that country to have an average 6.8 children per woman. That's the fertility rate, the Y variable. All right, consider the residual plots. Was a linear model appropriate for this data set? Well, let's look. That's the residual plot right there. That's the same residual plot, but with smaller dots, because that's how StatCrunch makes them. And there's the Excel residual plot. So was a linear model appropriate? Sure. There's no U shape. There's no pattern to this. There's no horn shape. So it's okay. You know, it could be better, of course, but what couldn't be in this world? So yes, there appears to be no pattern or horn shape to the residuals, so a linear model was appropriate. Did this data set have any outliers or influential observations? No, not really. I mean, you go look at them, there's no points that are really far away from the rest of the group. Okay, so the U.S. had a female literacy rate of 99%. What would the model predict would be the U.S. fertility rate? So you put in 99 in the equation that you found. So you take negative 0.0487. Matter of fact, I'm going to put that right here. So this is 4.3 example 10. Make sure you're saving, by the way. My computer crashed on me during the middle of one of these videos just 2 videos ago, and it was very frustrating. All right, so let me make this smaller so I can see what I'm doing here. So equals negative 0.0487 times 99 plus 6.80. And there we go. This is the fertility rate. All right. What was that? 1 point. I've already forgotten. This can't be a good sign. Getting old. 1.98. All right. So 1.98 children per woman. All right. So the actual fertility rate is actually 2.1. So find the residual. So remember, residual is equal to 2.1, observed minus expected. So you go 2.1 minus 1.98, and then you just find that. So, boy, we're really not doing much in this particular problem, but that's okay. Residual is equal to 2.1 take away 1.9787. And there we go. This one's a positive one for once. So it's positive. We overestimated. So notice it's being positive residual. So we underestimated the value or the fertility rate. We guessed that it was going to be 1.98, but it was actually 2.1. So women in America are having a little bit more children than we expected based on the model. All right, I know there isn't much in that Excel spreadsheet, but it's still valuable stuff to prove that you know how to use it to do calculations like this. So I'm going to save it. And then we are going to meet back here for section 4.4, which has got some pretty heavy Excel lifting going on. I'll see you then.